Hello YouTube, and welcome to Flow Tectonics and how to predict earthquakes using flow tectonics modeling. We'll start off with the magnetosphere. You see the lines of flux that the magnetic field emanates from the earth, and the flow and flux comes from the South Pole, goes around, goes to the North Pole. So we'll start there as the general principle on how flow tectonics work. And then we've got a Google Earth here, and we'll start off with the Earth and note the weather. Now this weather is slowed down 650 million times, i.e. it's just a snapshot, but that's how our crust of the Earth appears to us. But we all know, you set the weather in motion, speed it up in real time, and you see it flow. The crust operates very similarly, so let's get rid of the weather picture, and you will note roughly here there seems to be an emanation of lines. This whole general area is where all the molten material from the Earth flows down from the North Pole to the South Pole. Then it comes out and spreads from the South Pole, heading back up north. So you can see stresses of connections. You can see how these two have stretched in between. And you can see stretch marks here. All that. So basically, as all this spreads out, it spreads into a larger circumference. The circumference here is bigger here. So it stretches apart like your fingers. So you say, what's going to fill that in? Well, there's also convection flows. And the largest convection flow is the North Atlantic spread. Using the Pangea model as a first good guess, true, stuff comes out of the south and goes to the north. That's why we have a predominance of land on the northern hemisphere. But to fill in the gaps of the spread as it goes to a larger circumference around the equator, you have the North Atlantic spread. And as it spreads like a conveyor belt, you'll notice it's basically equal distance between the middle point of the spread and the sides. So as this spreads equally, you're going to have an equal distance, hence the same pattern on both sides. They don't fit together, they never did. What they do is they spread out and they move across at an equal rate. Hence you have the same shape. So as the entire crust heads north and this spreads to fill in the circumferential gap, once you cross the equator, the circumference starts to get smaller and all the land starts to compress. So the Pacific plate is the largest whole plate that moves basically just north. You can see the stretch marks here. We'll get into that tectonic activity on that side in a moment. But looking at Hawaii as an example of how the plate is moving, the plate is moving up and over before, because you can follow the old Hawaiian chain all the way up. The plate just goes until it finally gets up into the trenches and then it just dives in. So here's the Hawaiian chain. It goes across here. These are old Hawaiian islands, millions of years ago. And they dive in here and are never seen again. So how old is the Earth? I don't know. It's been mixing for a long, long time. But you can see the Pacific plate rises and then pushes over, which is very similar using the spread of the North American plate. It rises up and gets shoved over this way. And the Hawaiian island chain roughly follows the same shape as this. So you can see how the whole plate rises up, is shoved over, subducts and grinds down to go back to the South Pole and repeat the process. If you model this with a computer, setting all the variables of flow, you will see a repeating pattern of continents being made. Matter of fact, that almost looks a lot like this. Acid comes out, you do see some subduction here, which changes the demographics, but being how you have a continent sitting right here, as it pushes up, you're going to see some subduction because it's not going to go through there, because this continent right here is pretty much locked in by this ring of land, because the North Pole doesn't have a big downdraft. However, Iceland is a downdraft. They say the Great Lakes is a downdraft. Yellowstone is a big downdraft. And that's where you have the plates come together and constrict because there's so much pressure they liquefy. They get very hot and downdraft, which reduces a lot of the pressure there. So this continent will eventually move up to here. This is not a stretch, but a slow activity. And when it does, it'll probably twist to where this end will get twisted over here. This may even drop down like Florida. And the next one will follow right behind it. It repeats, and you say, well, why is there a gap here? It could be, as the Milky Way galaxy goes around, it's a cold spot. It just doesn't spread so much, so there's less activity along that area. Along the same line, if you follow this out here, going up this way, and you can see the stretch marks here, the African continent and the Alps, if you shove those two together, while they continue to move this way, because remember the Atlantic spread, basically you have three zones: the Pacific plate, which moves north, the eastern Atlantic spread, North America, well, the Americas continent, we'll call that zone 2, and then you have the this is the western, this is the eastern side. So you have the Pacific, eastern and western areas, and those are divided into two sections, the northern and the southern, because they are moving differently to each other. So the African shoves up this way. A couple 100 million years from now, here's the tip of Africa in India. And the Alps now have become the Himalayas because they shove up there. Which is why you have a tremendous amount of earthquake activity along here, because again, it's divided in half. Which is why Japan, which is the corner of the lower half, is just sitting there, and it's being shoved over by the whole spread. And the whole spread of the African continent moving up this way, Japan's on the end just vibrating like crazy. This is more or less landlocked, for lack of a better term, but it's also compressing and moving. It's kind of like scum floating on a river flow of water. It's just kind of sitting there and it's eating away here and there. A lot of land mass gets trapped up here. That's where out here you have the flow and the spread. So there's roughly, the push comes along crust here as it pushes across the more stable